Well, as long promised, here it finally is. This is the full 3D design software tutorial of the F16 I designed in Plasticity. I transferred over for this type of work from Fusion 360 to Plasticity primarily because I was frustrated with some of the tool set. A little bit. When designing something, this curvy. To be clear, there's much I love about Fusion 360, but for this type of work, I like the process in this program. In fact, I find it fun. I've regularly been putting out design tutorials for Fusion 360, but I've only used Plasticity for about a month. So for this short time, I hope it will help you see what is possible for you if you want to give it a try. Speaking of giving it a try, check out my affiliate link in the comments for a free trial download, and then try it for yourself and follow along on this video. I'm going to show you the full process of how I modeled this awesome jet. I know I learned quite a bit in doing it, and I think you will too. To start with, I want to introduce you to one of my favorite websites that I use to find schematic plans of aircraft in the first place. This is called aerofred.com. There are many places where you can see schematics and images as well, but this happens to be one that I prefer, and a lot of times you can find quite a bit of additional information. Scrolling through the site, I found a plan for a large-scale RC jet originally designed by Giant Jets, Inc., and apparently restored by Great Plans in 2009. I don't really know what that means exactly, but at any rate, the plan is available on the Aerofred website for free. This version of the plan is approximately 7.5 feet long originally and was powered by a giant-scale nitro engine with a tuned pipe. I'm sure it was awesome, but I think I've flown my last nitro airplane. Electric is just way easier, way more reliable, and way less messy. Also, there's very little of the construction details of this plan that I intend to follow at all. I'm simply using these plans as a reference for the geometric shape of the model, and I think they did a good job. So we're going to use what we can on this to create some sketches and create our own model to the scale that we want. My intention is to use a 50mm EDF fan, so I'll design this model around that. My first step is to jump into Fusion 360 and open a previous model of that EDF fan. I will export it as a step file and then import it directly into Plasticity. Now, incidentally, this works both ways, which is pretty cool because I can use Plasticity for what it's strong at and bring a fully editable part, or plane for that matter, back into Fusion 360 if I choose. Now, why would I want to do that? Well, check out my retractable F16 landing gear video in Fusion 360. Now, that's an ideal Fusion project and not something I would likely want to tackle in Plasticity. I'm sure it could be done, but since I use both, I'll just leave the gears and joints and motion studies to Fusion for now. For this model, I'm not interested in a specific scale factor. Rather, I simply want all the parts to fit. So I'll be scaling these plans to a size that I feel is reasonable. To start with, I simply import them. Once this is imported, I will move them where I want them and begin scaling. They come into Plasticity as what's called an empty, and they're very easy to work with. You can rotate them and scale them just like any other entity. First, I use a rough scale factor. Then, to be more precise while scaling, I select F for freestyle. Now, make sure to select the uniform scaling option when you do this. Now, then I can be very precise about exactly a length of unit I want to scale it to. I'm going to import plan view and profile view as well as some section views to reference the formers. You'll often find discrepancies between these views as to scale, so it's great to be able to so freely scale these to exactly what you want. And once I have these all set up and rotated to their corresponding views, I'm ready to get started. Okay, let's have some fun. I wanted the single seat version of this, so once I got done, I just simply slid it down to the full profile. Lofting two control points like this provides for a tangent curve. So I think you get the idea on the tools that I'm using to do these sketching between splines, between lines, between raise degrees, between trimming, etc. So I'll stop putting these prompts up. By the way, are you noticing where I'm toggling between control point, edge, face, or body at the upper left? These are controlled also with keyboard shortcuts 1, 2, 3, 4, and 5 for all of them. Okay, this is important, or at least I thought so. You see me drawing a line here, and I'm using one of my control points, and I'm snapping it directly to that line. Since that is the same line or plane as the original one, that actually will create a tangent curve from that point, so you shouldn't see a seam when this gets mirrored. I'd really appreciate any comments, questions, or suggestions that you might have to make these videos more enjoyable for you guys. Please leave them in the comments below. Okay, I have most of the formers I want to use. This is incomplete. I'm going to look at my one that I didn't record. And what you see is that this steps out. So I need to create one right here that didn't exist before. And then we need to make this beautiful curvature for the front. I'm lofting between these two formers so that I can get an idea of where this shape should be, and then I'm going to use the imprint command. Using the raise degree command, Shift S here, and then toggle control points display. Then I can simply move those control points to add additional bow to this section. I'm doing a trial loft here, and I'm using a guide rail to keep it from being too wiggly. You can see it change. So I'm giving it another try here. I'm going to straighten out the curvature a little bit, and then we'll loft it again to see if I like that a little bit better. I'm also using the scale factor on the formers to move those out. I'm redoing this bottom rail here. Notice that I'm using spline curve, not control point spline. I'm using the Nurbs command here, and I'm using the formers as guides on this. I'm going to right click on toggle render mode here because I want to be able to use a different shader that helps me to see curvature a little bit more cleanly. Once bodies are joined, I can toggle surface mode here and simply select the both and hit J and clean up geometry. Sometimes this works. I made a mistake somehow here, and I'm seeing the seam on the top, so I'm going to create a cube, and then I'm going to Boolean subtract this from the top of the model. Once I have that done, I'm simply going to do a loft command with proper tangencies. Working on the nose cone now, I'm going to trim to get my profile exactly the way I want it. Then the profile edges vertically I extrude out so that when I loft this, it will simply allow me to it will hold the proper curvature. And since I messed the last one up, I'm going to mirror this over very quickly so that I can check to see if I can see a seam. I will turn off lines, and it looks perfect. I'm going to extend my edge out here just a little bit temporarily, and then I create a cube where I'm going to put it exactly where I want it, and then use a Boolean operation. Oh, sorry, no, I split the nose cone, and now I'm just going to trim by the faces of those so that I have one section of this that works the way I want it, and then I'm going to begin to use the raise degree command on that one surface. So you see me stepping it in a little bit tighter here. And then once I have it where I like it, then I can begin to, well, I call it grip bedding. I can move the control points as I see fit to try to get it to follow my profile, and it creates a very organic shape. Once you like it, make sure to use the toggle points command to get rid of all those dots. They get very confusing very quickly. So I knew this section of the plane was going to be hard, and it didn't disappoint. I struggled with this area quite a bit. You see me here using Nurbs to get this in, but I have a little bit of a divot or a concave area under the canopy that I just don't quite like the lines of. So I experiment with creating more control lines here and whatever else I can come up with, but it just doesn't seem to help so much. Honestly, I will just let you guys run through this section as I try multiple things until I finally get it the way I like. So what was the solution? Actually, I guess I would have to say all of the above. I used Nurbs, I used a little bit of lofting in some areas, and I used patching. Maybe I just used a sledgehammer to beat this thing into submission, but I finally got it the way I wanted it. Okay, thanks for hanging with me this far. We are only halfway there, and YouTube likes these things broken into more manageable videos. So I'll be covering the rest of this in the very next video. I'll be covering the canopy creation, tail surfaces, and wings in the next video. So like and subscribe to make sure, and get it. Remember, there is a free trial of the Plasticity software, so use my affiliate link in the comments. If you like it as much as I do, then use my discount code REDBARON at checkout and get 10% off the purchase.